Did you know that the way we configure electrical circuits can change how they behave dramatically? A small change in configuration can mean the difference between a device functioning properly or failing completely. It's surprising how much impact these choices can have on our daily lives. Hi there, welcome to today's video where we'll talk about circuit configurations and how they affect voltage, current, and resistance. I've learned that understanding these configurations is crucial for anyone working in the field. In this video, we'll explore series, parallel, and the more complex delta and Y configurations. You'll gain insights into how these setups impact electrical properties, and we'll also share some real-world examples of where you might encounter them. By the end, you'll have a clearer understanding of these concepts and their practical applications. So let's get started. Number 1, series circuits. As mentioned in the previous video, in a series circuit, components are connected end-to-end. This means that the same current flows through each component. Here's the key formula to remember. Voltage V equals current I times resistance R. This is Ohm's law. The total resistance is simply the sum of individual resistances. Our total equals R1 plus, R2 plus, R3, and so on. Important insight. If one component in a series circuit fails, the entire circuit is interrupted. This principle is often seen in string lights, where one burned out bulb can cause the whole string to go dark. Number 2, parallel circuits. In contrast, parallel circuits allow multiple paths for current to flow. The voltage across each component remains the same, but the total current is the sum of the currents through each parallel branch. The formula here is total current I equals I1 plus I2 plus I3, and so on. The total resistance can be calculated using 1 divided by R total equals 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3, and so on. Key takeaway: if one component fails in a parallel circuit, the others can still function. This is why home electrical systems are typically wired in parallel. It provides reliability. Your home's light circuit is typically in parallel because you can switch on one room while leaving the rest of the house switched off. Another insight about parallel configuration is that it decreases the overall resistance of the circuit. Number 3, combination circuits. Many real-world circuits are a mix of series and parallel elements. These combination circuits require solving step-by-step by breaking them down into simpler parts. Lastly, delta and Y configurations. Now let's discuss delta and Y configurations. These are common in three-phase power systems. In a delta configuration, the components form a closed loop. This setup is typically used in high-power applications, such as motors. One notable aspect is that it provides a higher starting torque. On the other hand, a Y configuration connects each component to a common point. This is often used in transformers and can help reduce the voltage in a system, making it safer for residential use. In industrial settings, delta configurations can handle larger loads, while Y configurations are generally used for lighter loads due to their voltage reduction characteristics. These two configurations will be discussed in detail when we dive into three-phase circuits. To summarize, understanding circuit configurations is essential for anyone dealing with electrical systems. Series circuits offer simplicity, but can be limiting, while parallel circuits provide reliability. Delta and Y configurations play critical roles in managing power in industrial applications. Understanding these concepts not only enhances your knowledge, but can also prevent costly mistakes in real-world applications. Remember, the way we configure our circuits can make all the difference. Thank you for joining us today. If you found this video helpful, don't forget to like, subscribe, and hit that notification bell for more content on electrical concepts. If you have questions or topics you'd like us to cover next, leave a comment below. Until next time, keep experimenting and stay curious.